Hello friends, welcome to Quick Learn website, and I am very excited to inform you that in Quick Learn I have recently launched my website, that is www.quick-learn.in. This website is especially for all the engineering and diploma students and those students who will preparing for competitive exams. So in the blog section of the website, you can find the notes of all the electrical and electronic subjects, just like basic electronics, microcontroller, microprocessor, power electronics, and slowly I will add more notes in the website. And if you are preparing for any government competitive exams, then check also my MCQ series, that is multiple choice question series, and previous year question papers. That will help you in your competitive exams. Here I also upload the quiz test or mock test for ONGC, UPPCL, or for different type of competitive exam previous year question papers. Or for latest update, please join my Telegram channel. The link of my Telegram channel I will give in my description box. So stay continue and keep watching and keep visiting my website. Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you comparison between voltage source inverter and current source inverter. And I also explain what is VSI and what is CSI. So this is lecture number 33 of Power Electronics series. So let's start with the topic. Before I discuss the comparison between VSI or CSI, first we know about what do you mean by inverter. So inverter is basically an electrical device which is used to convert fixed DC power into controllable AC power. Or we can say that inverter is basically a DC to AC converter. So this is an inverter. The input of the inverter is DC power and the output is AC power. So we all know about what do you mean by DC, direct current. Direct current means indirect current, the flow of electric charge only in one direction. Or we can say that the magnitude of electric current cannot change with respect to time in case of direct current. So this is the input of the inverter. Now, inverter convert DC power into AC power. So, what is the AC power or AC current? AC is basically an alternating current. This current change with respect to time. Or we can say that the magnitude of the current is changed with respect to time. That is called alternating current. So, the device that converts DC current into AC current is called inverter. Now, the question arises, from where inverter get the input power? It means from where inverter get the DC power. So the main source of DC power is the battery. So inverter take DC power from the battery and convert it into AC power, and this AC power is used at the time of power failure. Because we know that in our home all the electronic equipments just like TV, fridge, washing machine, all are operated with the help of 220 volt 50 Hz AC power supply. So at the time of power cutoff or at the time of power failure, all these equipments are not working. And if we want to operate that equipment at the time of power failure, we use inverter. So inverter take DC power from the battery, convert it into AC power. Now this is the main application of inverter, or we use inverter in our industries also. That inverter is called power inverter. Power inverter are basically used to convert bulk DC power into AC power. So that is called power inverter. Now inverter use force commutation. So before I discuss force commutation, we must know about what do you mean by commutation. So commutation is basically a process to turn off any device. If we want to turn off any device or any equipment, that process is called commutation. So there are so many type of commutation process. First is most commonly used commutation is called self commutation or line commutation. This is also called natural commutation. So first is line commutation, also called natural commutation or also called self commutation. In case of self commutation, let us assume this is the circuit. Here we give AC power supply, and this is our main component of the circuit, that is the diode. Let us assume here we use diode, and this is the load resistance RF. Now, when we give AC input supply during the positive half cycle of the AC supply voltage, what happened? During positive half cycle, this terminal is positive and this terminal is negative. So, current flow in this direction. When current flow in this direction, the diode is start conducting, because when anode is positive with respect to cathode, diode start conduct, and it is behave like a closed switch, and current flow in this direction, and we get output voltage across the load, V output. But what happened during the negative half cycle of the supply voltage? Because we give AC supply at the input side. So when negative half cycle will appear, this terminal is positive and this terminal is negative. So during negative half cycle, current flow in reverse direction. In reverse direction, the diode is turn off and behave like a open switch. When diode is open switch, no output voltage across the load this time. So we can say that when the applied voltage is reverse bias, diode is self-commuted or self-turn off. So this process is called self-commutation, or also called line commutation or natural commutation, because naturally when the negative half supply will be appear, the device will be turn off. But if in place of this diode, here we use some other device that is not commuted during the negative half cycle, what we do? We use a external, that time we use a external circuit to turn off this device. This external circuit is called force commutation circuit. This circuit will forcefully turn off this device. So this is called force commutation. So inverter use this type of force commutation circuit. It means additional circuit to turn off the inverter. But force commutation having lots of disadvantages. Just like if we use force commutation, the circuit complexity get increases, because here we use additional circuit to turn off the device. Next disadvantage is the cost of the circuit will increases, because here we use additional circuit. Third is the size of the circuit is also get increases. So there are lots of disadvantage of force commutation. So to avoid the force commutation in inverter, here we use some power electronic devices just like IGBT, insulated gate bipolar transistor, MOSFET, metal oxide field effective transistor, JTO, gate turn off transistor. These devices having self commutation property. So if we use these type of switches in inverter, we not required force commutation circuit. So this is all about the basic concept of inverter. Now the classification of inverter. There are basically major two type of classification of inverter. First, the classification of inverter according to the source of inverter, and second is the classification of inverter based on connection. So first classification is based on the source of inverter. It means which type of source we use in the inverter. So first classification is voltage source inverter, that is also called VSI, and second is current source inverter. Voltage source inverter is further divided into two types, single phase inverter and three phase inverter. Next is classification of inverter based on the connection of the power electronic device. So there are three type of connection of power electronic device in inverter. First is bridge inverter, series inverter or parallel inverter. So these are the major classification of inverter. So in this video I will explain you the comparison between voltage source inverter and the current source inverter. Now, what do you mean by VSI and what do you mean by CSI? So before I discuss the comparison between VSI and CSI, we have to know what do you mean by VSI and what do you mean by CSI. So in case of voltage source inverter, we required a constant voltage at the input side of the inverter. That inverter is called voltage source inverter. Here we see in case of voltage source inverter, we required a constant voltage at the input side. Next is current source inverter. In case of current source inverter, we required a constant current at the input side of the inverter. That inverter is called current source inverter. So, if a constant or step voltage is given at the input side of inverter is called VSI, and if a constant current or step current is given at the input side of the inverter, that inverter is called CSI. This is the basic difference. Now, how we obtain constant voltage source at the input side of inverter? So, to obtain constant voltage across the input side, here we use a DC voltage source, and in parallel with this DC voltage source, here we connect a capacitor. The capacitor is just like whose capacitance is very large. Because the capacitor having large capacitance will store more charge, and the voltage across the capacitor is also large. And the second property of the capacitor is capacitor cannot change the voltage instantaneously. It cannot change the voltage instantaneously. It means capacitor maintain a constant voltage across the device. So DC voltage source and capacitor both are connected in parallel. So the voltage across both of them is constant. That will help to maintain constant voltage across the input side of the inverter. Now in case of current source inverter, we have to maintain constant current at the input side. And we also know that constant current source is not exist. We have to make constant current source with the help of voltage source. So to make constant current source, here we use a DC voltage source, and in series with DC voltage source, here we connect an inductor whose inductance is high. And we know that inductor having a property, inductor cannot change current instantaneously. And the second property, it also not allow the flow of reverse current. So there are basically two property of inductor here we use. First is inductor cannot change current instantaneously, and second property is inductor also not allow the flow of reverse current. So in this way, the current flow through the DC source is not change across the inductor, and it also not allow the reverse flow of current. So that will maintain a constant current across the input of the inverter. So in this way we make CSI. So to make VSI, here we connect DC in parallel with capacitor, and to make constant current source, here we use a voltage source, that is DC, in series with inductor. So this is the basic difference between how to make VSI and how to make CSI. Next difference is the power handling capacity of voltage source inverter is low as compared to current source inverter. Because in case of voltage source inverter, here we use high switching speed devices just like IGBT, MOSFET or power semiconductor devices. These power semiconductor devices having high switching speed, it means these switches are turn on or turn off very fast. So due to high switching frequency, these type of switches produce high harmonics in their waveform. Due to this high harmonics, the power handling capacity of device is low. So the power handling capacity of voltage source inverter is few milliwatt. Next is in case of current source inverter, the power handling capacity is high, because in current source inverter, here we not use power transistor just like IGBT or MOSFET. Here we use thyristors or JTU, and we know that the switching frequency of thyristor and JTU is low as compared to IGBT and MOSFET. So due to low switching frequency, the harmonic produced is also low. The power handling capacity of device is high, that is 10 of milliwatt. So this is the second difference. The third difference is here we use power semiconductor devices whose switching frequency is high, just like IGBT or MOSFET. Here we use low switching frequency devices just like thyristors or JTU. Next difference between VSI and CSI is, in case of VSI, here we use pulse width modulation technique to control the switching speed of the power semiconductor devices. In case of current source inverter, here we not use pulse width modulation technique, because in case of VSI, here we use pulse width modulation technique. And we know that the switching speed of the IGBT and MOSFET which is used in inverter is very high. So this is the turn on time of the switches, and this is the turn off time of the switches, and this is the total time period. This is on time or this is off time. So to control the width of the pulse, here we control the switching speed of the device. So in case of voltage source inverter, here we use pulse width modulation technique. But in case of current source, here we not use any pulse width modulation technique, because here we use low switching frequency devices just like thyristor. And in case of thyristor, when we turn off the device, the current across the thyristor is not zero suddenly. It will take some time to decrease to zero. That is the reason here we not use pulse width modulation technique. So these are the basic difference between VSI and CSI. Now with the help of circuit diagram, I have explained you the basic difference between CSI and VSI. In case of voltage source inverter, as I have already told, we have to maintain constant voltage across the load. So how to maintain constant voltage? Here we use DC voltage in parallel with capacitor. That circuit will maintain a constant voltage across the input side. And in case of current source inverter, here we have to maintain constant current across the input side. So to maintain constant current across the input side, here we use DC voltage source in series with inductor. This will maintain constant current across the input side. This is the first difference. Here we see in the circuit diagram. Now the second difference is, in case of voltage source inverter, we use power electronic switches just like IGBT, power MOSFET. In case of current source inverter, here we use thyristors. So this is the second difference. To maintain the switching speed of the power electronic device, in case of VSI, here we use pulse width modulation technique. But in case of current control device, here we use thyristor. So we don't use any pulse width modulation technique, because the switching speed of thyristor is very low as compared to IGBT or power MOSFET. The complexity of circuit is large in case of VSI as compared to the CSI. So these are the basic difference between voltage source inverter and current source inverter. Now some more difference are given here. When the DC voltage remain constant at the input side, then this voltage source inverter is called VSI, or also called voltage feed inverter. Next is when the input current is remain constant at the input side. That type of inverter is called CSI or current source inverter. This is also known as current feed inverter. Next is, in case of voltage source, we feed a stuffed DC voltage or constant DC voltage at the input side. Whereas in case of current source inverter, we feed a stuffed current source or constant current source at the input side. Next is, a voltage source can be converted into current source by connecting a series inductance and then varying the voltage to obtain the desired current, because we know that current source cannot exist. So we make current source with the help of voltage source. Next is, a voltage source inverter can also be operate in current control mode. Similarly, current source inverter can operate in voltage control mode. Next, inverter are basically used in variable frequency AC motor drive, uninterruptible power supply. It means in UPS, induction heating. These are the application of inverter. Next is, voltage source inverter drive are typically more efficient than current source design, or we can say that voltage source inverter drives having high efficiency than current source inverter drives, because voltage source inverter drive using high switching speed devices just like IGBT or MOSFET, whereas current source inverter device using less efficient device just like GTO or thyristors. Now this is the whole explanation of voltage source inverter and current source inverter. How voltage source inverter we make, how current source inverter we make, how voltage source inverter function, how current source inverter function. So these are the basic concept of voltage source or current source inverter. Now here I discuss the complete comparison between VSI and CSI. So first difference is the voltage source inverter input voltages keep constant. In current source inverter, input current is keep constant. Next is in voltage source inverter is feed from a DC voltage source having small or negligible impedance. Current source inverter is feed with adjustable current source from a DC voltage source of high impedance. Next is to make voltage source inverter, here we use a DC voltage source in parallel with large capacitance. Now in case of CSI, here VSI can be converted into CSI because we know that CSI is not exist. So VSI can be converted into CSI by connecting large series inductance. Next is the input voltage is made constant. In case of CSI, the input current is made constant. Next, in case of VSI, an output voltage is independent of load. In case of CSI, output current is independent of load. Next is the waveform of the load current as well as its magnitude depend upon the nature of load. In case of CSI, the magnitude of output voltage and its waveform depend upon the nature of load impedance. The next difference is in case of VSI, VSI has slow response than CSI. CSI has faster response than VSI. Next is VSI required feedback diode, but CSI does not require any feedback diode. In case of VSI, the commutation circuit is complicated. It uses current commutation. In case of current source inverter, commutation circuit is simple. It contains only one capacitor. It uses voltage commutation. Next is the power BJT, just like power MOSFET, IGBT with self commutation can be used in voltage source inverter circuit. In current source inverter circuit, here we use thyristors. Next, in voltage source inverter, diode are connected in parallel. In current source inverter, diode are connected in series. Last difference is, in case of VSI, we use pulse width modulation technique. In case of current source, here we not use any pulse width modulation technique. So these are the basic difference between CSI and VSI. Hope you enjoy the video. For more interesting video, please like, subscribe and share my channel. For notes, please visit my website. So stay continue, keep watching and keep sharing my videos. Bye bye.